Cool.
Ready?
Yeah.
So what we do is we oftentimes will start off with a set of produce where it's just, set out in these small different plants that we're actually starting to plant here. And then we transplant them to an individual cell. Now the reason we do that here is because we want to make sure that every one of the produce cells is actually generating a plant. And not all the seeds germinate. I mean, you may have a 98% germination ratio, you might have a 94% germination ratio, but we don't want to lose 5% of the produce. So we start them off in smaller trays and we transplant them to cell trays so that every single tray has a plant that's going to be viable and is going to grow to fruition. Now what you see over here, for example, is some of our Encore lettuce. Isn't that wonderful? And I'll tell you one over here. Come over to this one here.
Is that basil?
Yeah, if you smell it, you can actually taste it if you like. You can pull the plant if you want, but isn't that wonderful? Isn't that smell great? It really is good. It really is good.
Wow.
And then we have our romaine, and again, you'll just see a variety of the different types of. This is a romaine
I feel
heart.
like I'm in Whole Foods.
Well, that's exactly right. That's exactly right. Because that's what we're trying to do is provide the freshest produce possible. And see, one of the things that occurs is when you have a produce grown in the field, you have to transport it. And when you transport it, you're having petroleum fuel costs to move it around. So we're kind of making a trade-off in energy to grow versus energy to move.
Right.
And this is local. As you know, we're sitting here on the Washington Mall. We can be sitting right next to Whole Foods. We can be sitting right next to a community center, a church pantry. We can do a variety of things, right? So we can be very local to the consumer, which means that the transportation cost is almost eliminated in the produce costs, and it makes it much more cost effective. Fuel prices have gone up about 25% since the beginning of the year. It's about $4 a gallon now, or $4.50 a gallon. The produce has gone up 23%. 23%, and it's because of fuel costs. I mean, I didn't know that actually when we got into this, but the two biggest costs in produce that you buy at the store are the fuel cost to produce it and transport it, and then the packaging. I mean, they have all this wonderful packaging. They talk about, it's organic, it's triple wash, just this, that, and the other. It could be from Yemen, it could be from Colombia, it could be from Mexico. And it's always transported in, then they package it, and so the actual cost of the produce is much less than what it takes to actually get it to the consumer in a way that we're used to buying. So we have these shelves. We have different heights. We use an LED technology. This LED technology saves us 60% of the energy. We actually use a system where we're able to. Well, in fact, I'll go over here right now. You just glanced over here. We have what we call a germination rack, and the germination rack allows us to start produce when it doesn't need light. When you plant it, it's in the ground. It takes 3 to 5 days to germinate. And it uses its geotropic knowledge as such to be able to find its rooting and go up towards the sun. And once it's into the sun, it's looking for the sun, so its petals open up and it's looking for the solar-tropic type light to come down for photosynthesis. So we don't want to spend energy just lighting up soil. So we start the plants over here, and then once they've started to have petals, then we move them over to the racks that actually have light. That whole maneuver is an enormous saving in time. We basically save 3 days of energy costs because we're now only putting the plants underneath the light when they have the ability to absorb the light for photosynthesis. So it's a very interesting piece of the process that we use in order to make sure that this is an efficient way of use of energy and that sort of thing. We also have in here different types of alfalfa and broccoli and other types of sprouts. And these sprouts are very interesting to the people who are consumers. People love to have sprouts in their sandwiches and different things like that. But one of the issues is that it's a high issue for pathogens because it's out in the fields and it's handled a lot. And so you see a lot of places that won't handle sprouts anymore because of the pathogens. Well, in this controlled environment, we don't have that issue. We don't have, you can wash your hands, you can wash your produce, there's nothing happening that's blowing into them, and so the produce is taken care of from a pathogen perspective very well. And as it is with sprouts, you actually don't grow sprouts in light, you grow sprouts in the dark. And then once they're grown, then you put them underneath light to kind of green them up. And then the heart of our system is our compost system, because we actually are organically certified, and so we have to have soil. So this isn't hydroponic, which is an effective solution, and it's not aeroponic, which is an effective solution, but it's terraponic. It's actually in soil. So all the nutrients are in there, you get the taste that you're looking for from the vitamins, and so you have a nice, rich, black soil. What we end up having, you see in here, is some of the plant matter that's still left. All the roots and all the leftover leaves go in here. So the grow worker is handling things here, planting trays or harvesting trays, and when they're done, they put them in here for the composting to occur. And the way the composting is sized, this is about 1/3 of the soil necessary to operate the entire grow center. So when you're harvesting every week, you're harvesting about every 21 to 28 days. And so we have enough soil to just keep operating the grow container on its own. This is the self-sustaining nature of it. We have enough soil. Once we start to operate a grow container, we don't add soil. We just keep enriching the soil and with its own nutrients to be able to get it back to a state that you actually have healthy soil to plant produce in.
Wow.
Isn't that neat?
Yeah.
And so there's actually a whole technology on this. It takes a long time for plant matter to turn to soil, but there's a technology that was developed years ago out in California called in-vessel static aerated composting. And what it basically means is they get air and heat going into the soil in such a way that you don't have outgassings of methane or other types of things which occur when it's an anaerobic composting situation. If you just put wet leaves on top of each other, they don't compost very quickly, and they give off methane as a gas, which you and I don't care about. But in California they cared about it because they had so much of it going on and they have such an environmental concern out there, they actually paid attention to it. So this way they were able to come up with a process that allows them to quickly change plant matter into soil, and we can do it in about 30 days. It normally takes 3 to 4 months. So with this process, it comes in. We could use worms, we don't add worms right now. There are a variety of things we could do to continue to enhance the composting system, and it's an evolving technology for us. It doesn't sound like something that you and I would do, but composting is a technology. There are whole companies out there that are renewing and looking at leading edge ways to have composting. So we think this fits for our particular application. We don't have complex things that we're putting in here like yard scraps and food scraps and things like that, like a restaurant might have or a municipality might have. We just have our plant matter and our soil, so we have a little more of a controlled situation. You'll also notice that we have these tanks underneath. On one side is a fuel tank, on the other side is a water tank. And the fuel tank on the large full grow center, the full grow center, you know, it's a whole hall of racks, right? And the fuel tank goes the length of the container, and the water tank goes the length of the container. That's what allows it to operate for over 30 days off grid. So we have solar panels to operate on some of the batteries. We're looking at wind turbines or some alternative energy. Right now we have a biodiesel generator that we use. We can go into an environment, we can operate for 30 days without any power from the local grid at all. They supplied us power at the show here, and what we do is we come in, when we landed, when we got here, we walked in, we pushed our generator button, we wait 20 minutes, you'll feel it kick on in just a second here, and now we're independent. And we're able to operate for 30 days from here. Isn't that fun?
Yeah.
We've another side note on the tanking. What ends up happening is with this large amounts of fluid that you have, you end up having a big heat sink, and so it stabilizes the temperature inside the grow container because it basically absorbs the temperature that's in the room. And once it's reached a certain temperature, if the temperature changes, like you take it to a colder area or you take it to a warmer area in transportation, we have these enormous, heat sinks that are just kind of slowly dissipating the temperature. So in a desert environment, we have heat during the day and cold during the night. This helps moderate the heat and cooling in the super grow container.
Wow.
It also keeps it in balance when you're moving it, which is another important thing if you have a mobile device. One of the other things you'd be interested in is we do have all the water that is here. I won't spray you accidentally. But we use a wand here to to take care of the produce and water it. What ends up happening is that the produce absorbs the water, and then it puts the humidity out into the air, the water out into the air through its transpiration process. It transpires water into the air. And that's what it also does the oxygen as well. It gives off oxygen, it gives off water. Well, you hear an air system operating right now. It's a dehumidification system, and it's also an air conditioning system and a heating system. So we capture all the water out of the air. If you've ever gone out to your air conditioner in the summer, you see the water dripping off? Well, that water comes right back into this tank. So the only water that really leaves the grow container is in the produce itself. So it ends up being a very efficient use of water, which in many areas is important. And of course, we want to be efficient with our water anyway, but it also allows us to be self-sustaining that much longer. The water that we use, most of the time you flood a field, it evaporates, those sorts of things. But we never do that. We give the plants just the water they need, and we recapture the water they transpire and put it back into our tank. Isn't that neat? So you did ask if we were insulated. This container, we work with a manufacturer who specializes in command centers for various types of organizations like the military or sheriff's departments or those types of fire departments. And so they take these containers and they're able to deploy this type of insulated facility as far away as Alaska and Saudi Arabia. So we use the same type of insulation that they use for those environments which have very sensitive electrical equipment in there. But we have very sensitive biological equipment called plants, and so we're using this very sensitive environment. We need to insulate it, and we use the same technology they use for the highest precision equipment in military and other types of applications. The other thing we have is that these lights are all controlled electronically. We actually can remote control these from the internet if we want to. And as you can tell, we're able to bring the lights up. We have a series of fans that we can turn on as well. And the whole environment here can be controlled remotely. This same iPad is a grow log, and so there's actually the operator who would be sitting here growing a plant. They harvest it, they weigh how much they harvested, they mark it into their tablet, they go to the next one, they compost it. And this whole process is occurring right here, but they have just an iPad tab instead of a flip chart, and they're just punching in information as they do that. So that if they do have a problem, then we can come in and assist them as well. If they're saying, gee, I'm just not getting what you expect. You told me we get 2 pounds a tray, I'm only getting 1.5. I don't understand what's going on. Well, we can check their water log, we can check their temperature settings, we can check the different types of things they would be doing accordingly. And if they really have a problem, they can take a high definition video, show it to us, and send it to us through the internet so we can support them remotely. So we kind of have this phone a farmer customer support, where we say if you have a problem, give us a call, but they more than give us a call, we can interact with them interactively, but also they can send us things that we can diagnose, almost like what we're doing with remote medical diagnostics. That's what we're trying to do with the plants. So the HVAC system is filtered here. When you're working with different things, you do get some dust in the air, and so we do have all the proper things that are necessary. We have an eye wash capability, and we have a little air mask if someone is using a lot of particulates in the air, like they've knocked up a lot of dust. But it all goes through a filter system, and the same filter system keeps out any types of cross-fertilization issues, as well as pestilence and that sort of thing. And then we have a little bit of a, see if I get this on here, I do have to wash up. There we go. So we have just a basic sink to be able to use the water. This water here that we capture back to a gray tank, just like you would in a RV, of some sort. And then you can more properly use that. You can use the water again if you haven't used anything in it that would void your organic certification, or you can dispose of it more properly without, like for example, we're here on the National Mall, we don't want to be dumping water out in the middle of the mall so that people are walking through puddles, right? So we capture the water and you can do with it as you want. So that's kind of the tour, and that's the full tour, to tell you the honest truth. I appreciate you listening. Do you have any questions I can answer for you?
Oh, I was going to ask, the other thing I could think of that you haven't already addressed is the water quality. Have you test the water, the tank?
Yep, there's a water filtration system that's not reflected here. It normally sits right here, and it actually allows you to have the watering so that we take all the different types of minerals and make sure it's the same type that are always coming out. So no matter what environment you're going into, you can have a high mineral content environment, and we pull out those minerals, and anything that would be even city water that would not be applicable to the plants, we're able to take the high chlorines out and that type of thing. So that's normally what occurs right here.
Oh, okay.
And just because it's the showcase one, we wanted more space.
Right.
It's a little bit more crowded than the actual grow center operated one. So.
Well, this is fabulous. Thank you very much.
Well, thank you very much. Thank you very much. Are we done?
Yep, good to go.